When we fetch data, they usually come from the web as static or dynamic content, or they can also come from relational databases and even from directory servers. In our examples here, as always, remember to try out the fetching commands we will be examining. Huge amounts of data are available over the internet. As a first example, let's see how we can use a command to fetch a complete book's content from the internet.
To fetch data from the internet, we use the curl command and specify a URL. In my case, I choose the book Moby Dick or The Whale of Herman Melville from the Project Gutenberg. This is a volunteer effort to digitize and archive cultural works. Passing the output to head, the book's first lines appear on the standard output. The "-s option of curl stands for silent mode and hides additional information while fetching the file. Furthermore, the compressed option is used to negotiate the transfer of compressed data. The output of curl is usually piped to another command or redirected to a file. For instance, I can pipe the output to wc word count in order to find how many lines, words and characters compose the file. We see that the book contains about 22,000 lines, 200,000 words and more than 1 million characters.
We can also use curl to fetch data from a website, for example, the dollar to British pound exchange rate.
A lot of information available on the web is accessible through web services. Consequently, apart from fetching static documents, we can use curl to invoke a web service and get some result. For example, here I ask for the exchange rate between the United States dollar and the euro, piping the result to JSON query, JQ, to display it more readably. I supply the services key with the API key variable. According to the result, $1 equals about 0.9 euros.
With JSON data at hand, we can run queries on it.
As a first step, I store the URL I'm interested in a variable named WGE because I'll use it repeatedly. The particular URL points to Wikidata, which is a universal collaborative knowledge base of open data. As you may guess, Wikidata is a derivative project of Wikipedia. Next, I run curl on this URL in order to find the identifier of the Moon, the Earth's satellite. I specify the WGE variable that contains the URL and pass as an argument a title with the value Moon. Then, I pipe the output of curl to JQ, requesting from the entities array the identifier of the Moon. We get that the identifier is Q405. We store that as well in a variable for further use. Here, I create a variable named MoonID and assign to it the Moon's identifier using the same commands as before, but enclosed in brackets. With MoonID at hand, we can now run one more query to find further information regarding the Moon. For instance, I repeat the curl command for MoonID, piping the result again to JQ in order to find the mass of the Moon, which is stored in an array named claims. As we see, the Moon's mass is around 73 by 10 raised to the power of 21 kilograms, which is about 1.2% of the Earth's mass.
A lot of data live in relational databases. Let's now see how we can fetch data from a MySQL database through its command line interface.
I first type a SQL query and then I pipe it to the relational database frontend, in this case the MySQL command. As you see, I echo select count star from projects, which is a table of the database I'm interested in, and then I run MySQL. With -u, I specify the username for accessing the database GHTorrent, which is a database with metadata of projects hosted on GitHub. Furthermore, with -p, I specify that I will enter a password for this username. Then, I'm prompted to enter the password and the query returns the number of records of the project's table.
All relational databases offer a command line interface.
Specifically, SQL Plus connects us to an Oracle database, OSQL is used to connect to the Microsoft SQL Server, with SQLite we connect to the SQLite engine, and with PSQL to PostgreSQL. Lastly, with ODBC we connect to any open database connectivity source. The ODBC command is available at the location specified on the right, and it allows us to connect to any database that is reachable under this Windows API.
Here is a great example that shows us how we can combine data from diverse sources. We'll fetch data from the internet and from a database and combine them together.
In this example, I print some details of the latest activity of some projects stored in the database. First, I select the project GitHub API URLs using the command select URL from projects, and I limit the returned results to 3. Next, I pipe the query to MySQL to access the GHTorrent database. Using the returned URLs, I then fetch from the internet details regarding the latest activity of these projects. To do that, I read each URL in a while loop, and then I use curl in order to fetch all project details using the GitHub API. The project details are returned in JSON format, so I invoke JQ to query them. This way, I print for each project the owner's login name, the project name, and the timestamp of the last push. After entering the password for the database user, these are the results I get for the 3 URLs.
Large organizations store directory data about their employees in LDAP data stores. Amazingly, curl allows us to fetch data from there as well.
LDAP stands for Lightweight Directory Access Protocol. As the name suggests, it is a lightweight client-server protocol for accessing directory services. To fetch data from an LDAP store, we pass as an argument to the curl command a rather unusual URL. This does not follow the HTTP protocol, the usual way to fetch data from the web. Instead, it follows the LDAP protocol, which is used to fetch data from a directory. After that, we specify the relevant arguments and the query we want, which sadly has a tricky syntax. In my case, I request the canonical name of a user named DDS. The output includes a distinguished name that uniquely identifies the entry of the LDAP store. As we see here, it consists of my user ID, the organization unit I belong to, which is people, the domain, and my canonical name, which is Diomedes Spinellis.
This concludes our unit on fetching data from remote services. Stay with us.